today we'll be discussing cloud connectivity from the plant Ethernet architecture. So this right here is just some design guides that are available on the Rockwell's website. The design guides go a little bit more in depth to specifically what I'm talking about with cloud connectivity on the plant 4 with your converged plant-wide Ethernet. These are really helpful material as far as implementation as well as specifics on the different architectures. So today's agenda, we're going to go an overview, a very brief overview of converged plant-wide Ethernet, CPwE. We're going to review some use cases on why you would want to have the cloud connectivity, and then some technology considerations when you're go ahead and implementing it. So we're going to begin with the overview. I'm sure everyone is familiar with this and has seen this at one point in time or another. This is the holistic view that was put together by both Cisco, Panduit, and Rockwell as far as what a complete converged plant-wide Ethernet would look like. We're not going to spend too much time on this. Specifically, what we will be discussing as far as cloud connectivity to do it securely would take place in what they would call the industrialized and demilitarized zone, the IDMZ. So this is a more logical layout of the CPwE. Again, this is set up, this is a structure of what the CPwE looks like based on a logical design. This design follows the Purdue model as well as the ISA 95. Again, it's very hierarchical, starts at layer 0 and works its way up to layer 5. Again, today, what we're going to be discussing with cloud connectivity is going to lie right here, where my cursor is, right here in the middle in this demilitarized zone. That's primarily where we're going to be focusing today, on how to set up secure access to the cloud so that everything below that, layer 3 through 0, is secure and there's no issues, but we're still able to access the cloud successfully. So in that space, what lives in the IDMZ specifically usually provides secure methods to both the enterprise network as well as access to the plant network itself. A lot of things you'll also find there is application mirrors, so that your enterprise zone can see your factory talk historian. Will set up Pi-to-Pi interfaces, remote desktop gateways, as well as Cisco Web Security appliances with a proper TLS, transport layer security, proxy server capabilities. All of those things we're going to talk about today, but those things live in that area so that people who are in the on the enterprise side, on the corporate side of the company, can see what's going on into the plant, as well as check on how productivity is without actually affecting anything on the plant floor. They would be secure looking at everything without actually dissecting or touching anything to disturb anything that actually is happening on the plant floor itself. When we're referring to the plant 4, we're primarily referring to the industrial zone, which is, again, as I said earlier, those would be levels 0 through 3 is the industrial zone, and then that's broken up into lower levels, levels 0 and 2, which would be your cell area and your area zones, and then level 3, which is your operations area. As I said, level 3 would be operations area, so a lot of critical monitoring, and that takes place on that instance of the plant floor. So a lot of those places where you'll have your core switches and some distribution switches, as well as a lot of your factory talk applications and your application servers will live on that operations side as well. Cell areas where a lot of us are most comfortable, layers, levels 0, 1, and 2, your automation control systems, SCADA systems, the meat of the network where a lot of the operations on the plant take place. With that, the plant-wide architectural zones each have a different network topology that takes place. And in general, for the cloud connectivity for converged plant-wide Ethernet, you would never want to put it anywhere on these lower levels at all. As I said, you'd want to put it in that above layer 3 right before you hit layer 4 in what they call the demilitarized zone. Putting it in any lower zone would be very bad for business. So secure application depends on multiple layers of diverse protection, and industrial security must be implemented as a system. As you see on the left, it starts at the device level. You want to make sure all the devices are secure, applications are secure, your computers and everything in your operations level is secure, as well as physical requirements, the network, and it's a tiered process. And you want it with your defense in depth, the shield behind multiple levels of security for countermeasures to reduce risk. You also want to have consideration the variety of vendors. If you have different vendors, solutions, make sure everything communicates well. You also have to be flexible. Every customer is going to have different needs, so this is not a, everybody needs to do the exact same thing. You have to be flexible. Some plants are going to have different needs than other plants as far as their connectivity and what they need in terms of their security and connecting to the cloud and how secure it needs to be. But with that, everybody needs to be consistent and follow the same safety measures and protocols, and use the standard bodies, governing bodies, and those are you see off to the left. They're different symbols: ISA, IEC, the Homeland Security. They all have their different. Everybody's flexible in terms of how you want to do your cyber security and connect everything securely to the cloud. But there are some bottom line protocols that need to be in place that all of those organizations agree that will help. So secure appliance depends on multiple layers, as I've already said, but deploying, identify, and mobility services within a converged plant-wide Ethernet architecture outlines several industrial security and mobility architecture use cases, that being with Cisco ISE for designing and implementing and deploying multiple devices within a factory talk applications throughout the plant-wide industrial network controls network infrastructure. There's some more literature on that, as it goes back to the first slide I showed you with the white pages. Deploying a network security within a converged plant-wide Ethernet architecture use cases for industrial automation and control systems. Those include segmentation, visibility, anomaly detection, mitigation, and intent-based security for OT. There is securely transversing data across the IDMZ. That needs to be done a specific way with considerations to help successful design implementation, so that the enterprise, as I was saying earlier, the enterprise network can see what's going on without actually affecting anything. And deploying industrial firewalls within a converged plant-wide Ethernet architecture helps mitigate those instances where people are unable to get in, and provides that segmentation and trust factors. So here's, again, literature and all of those different things. Those are the links to the different white pages that I showed on the first page. Again, this goes back to, as I was saying, defense in depth. There's different layers with risk assessments, risk mitigation, and the management of the organization is key to all of that. This framework you see off to the right are different steps. The first thing you want to do is prepare. From there, once you prepare and you know what's going on, you can categorize, select the controls, implement the controls, assess the controls, authorize the system, and monitor the system. It's very, it's a lot of steps, but it's very easy to follow if you understand what's going on. And the risk management framework provides a process that integrates security and risk management, but it also helps look at the life cycle of what you have going on in the plant, and we'll look at that also. So the review for use cases, Control Flash Plus has the ability to reach out to the cloud to check the lifecycle status and revision availability of specific devices. This information is um, obtained from Rockwell Automation product compatibility and download center, the PCDC, via an API. When signaled into the PCDC within Control Flash Plus, cloud connectivity allows you to download firmware versions, release notes, and view import notices. Cloud endpoints that Control Flash Plus may reach out to, is brought up by TLS or HTTPS within the Rockwell Automation.com high-level domain. So with this last bullet, when it refers to the URLs, the TLS, and the HTTPS, so whenever you're on a website and you're logging into your bank account, for instance, and on the web bar, you see that has a little lock on the top left. That's what HTTPS is. It just means it's a secure connection. It's not easily broken into. Again, that's the security authentication factoring into that. And the diagram off to the right shows what it would look like when you have Control Flash Plus, and it's actually going out and it's checking to see if something is active in the life cycle. And when it does, it'll actually pull in the device information, and it'll show you the different revisions, and then it'll show you if you are downloading it. It shows you specifically where it saved it on your computer, on your file path. Factory Talk Asset Center. Asset Center has the ability to reach out to the cloud to check life cycle statuses as well for specific devices. This information is acquired the same way it is for Control Flash Plus through the PCDC via an API. The retrieval device cycle information from the PCDC occurs on the Asset Center server, and you'll see a screenshot of that over on the right. So when you're actually accessing Asset Center, you can actually see where it is, if you click on a specific, it's checking and seeing what's active and what's not. Asset Center has the ability to reach out to the cloud and check lifecycle. Excuse me. Again, it's PCDC through APIs. It's also using TLS and HTTPS for secure connection. You have the ability to schedule this or have it a manual process as far as updating and downloading. You can schedule it, as you see here on the right, through an Asset Center. You can go in and schedule it. So it does not something where if you don't want it running at a specific time during the day, or if it's something that you want to initiate yourself, you have those options to schedule it out or manually do it yourself. Factory Talk Activation Manager. Factory Talk Activation Manager has the ability to reach out and obtain new activations and rehost or renew existing activations. The cloud endpoints for Activation Manager may reach out again the same way through TLS or HTTPS. Again, those relied on Rockwell Automation's website through a secure URL. And you see on the right what it would look like. So new activation, you just punch in the serial number and it'll check for that. So some technology considerations when you're implementing these. As I said, it's going to live primarily it's going to live in the IDMZ. Now with that, as I said earlier, you're going to have applications that live in here, such as your firewalls, your Pi-to-Pi mirrors for your Factory Talk Historian, your remote desktop gateway services, your Cisco Web appliance that would actually have the capability to use TLS when you're connecting to Rockwell's secure website for those APIs and to check for those updates and lifecycle statuses. So proxy servers. again, these are going to reside your IDMZ, and it's going to be between the trusted and untrusted zone within that IDMZ. The inner concepts request from the client that the proceeds to take the connection on behalf of the client server. Forward proxies handle requests of a group of clients to an unknown and untrusted device outside their control, also known as the internet. Reverse proxies are intended to protect servers on the same network as the clients. Essentially, you'd have a proxy server set up in the IDMZ when Control Flash or Activation Manager or your asset center is reaching out to the Rockwell website, it is going to go through the proxy server to secure your connection before it even attempts to connect to the website. Is essentially what the diagram on the right is showing, and vice versa. Once you connect and you're downloading that information back, the proxy server is going to ensure that everything is secure and good to go before it comes back down to you. The proxy server is essentially is the Cisco Web Security appliance. It's physical or virtual. You don't have to buy an actual appliance. It could be a software appliance. You don't have to buy the actual hardware. It does analyze and categorize known URLs and blocks those that are falling below the determined security threshold. It provides the TLS and the proxy services, as I mentioned, and it contains the integrated malware detection to analyze the HTML, images, flash files, and more. Essentially, as I said, it's checking whatever you're downloading and whatever you're viewing. It's trying to bring back the information back in. It's checking all of that to make sure there's nothing that has malicious intent on the way in. TLS, as I mentioned, transport layer security, that is what encrypts the information that's going across from the network to Rockwell and vice versa. In the CPwE cloud connectivity, the endpoints may have factory talk, application, and cloud hosted destinations. A consideration for TLS is to ensure a trusted relationship between the devices as accomplished using digital certificates. TLS traffic presents a challenge to monitor and inspect traditional tools because traffic is encrypted. TLS proxies can be used to decrypt and intercept traffic. So the diagram over on the right kind of shows how it works. Essentially, the client computer would be your asset center or your cloud flash reaching out to check life cycles or get revisions. So the first thing it's going to do is it's going to request identification, and from there it's going for after request identification. The first thing that's going to happen is from that, the very first things that happen, Rockwell has a certificate authenticating that they have TLS and HTTPS. I don't know if any of you have ever been on a website and you go to log in to a website, but you get a pop-up box that says the certificate on this site is not trusted. Do you want to proceed, yes or no? That is the website not updating their security certificates with the authority, the governing bodies across the globe, and showing that they have a secure website. So that's the first thing that's always done. From that point, your computer, the first thing your computer is going to do is reach out and request identification. The server is going to get a public key. That key is then used to unencrypt the data, and all of these sessions thereon continue on. And all of this happens at super fast speeds that when you're clicking on a website, all this information is processed in the same process at the same time. So you don't even see this happening. This is all going on in the background. So when you're using a proxy, such as a proxy server, the proxy server is doing all of the requesting of a private key to unencrypt and decrypt the information. As it's doing that, it's sending the information about itself, not the actual computer. So your server for wherever you have your factory talk installed is not actually sending out any information about itself. It's all going through a proxy, and it's starting a session key through the proxy. So all that communication from Rockwell would essentially take place on the proxy server, not on the actual network itself. So this is how it would work as far as a proxy server and a proxy server in place. Now there are transparent and explicit. Um, they're they require two different there are two different processes in which this communication can happen. Proxies require a method to intercept the web traffic in order to inspect it. Um, transparent or explicit are the different modes on how the proxy server works as far as the HTTPS or TLS connection. The Web Security appliance, the WSA, initiates communication. And then to the web server. Transparent proxies rely on the infrastructure to intercept and redirect traffic. Explicit proxies rely on the client to send traffic directly. So how it would work essentially is the user initiates a web connection, and then that's the very first step. So from your computer it goes up, you connect to the web. Your Cisco ASA, which is your firewall that's in place to prevent outside traffic, from there sends that traffic through the web security appliance. In this case, in this diagram, it's a Cisco WSA. The WSA then checks the traffic to ensure that it's okay, and then it allows the traffic to be then forwarded on, in which case the web security appliance on the other end receives the response from the website. So server sends out the information requesting lifecycle check, goes through those processes, and then once it gets, Rockwell receives it, gets the information, it is sent back. So it's receiving the response from Rockwell, and then it checks it, and then it's going to then return the traffic back to Factory Talk, Control Flash, or Asset Center, whether or not what the lifecycle is after it does its process and checked. And as all of this is done, Rockwell has no idea there's a proxy server in place that's inspecting and decrypting the data going through. On a explicit proxy server, it initiates the same way. User connects directly. Instead of going through the firewall, it goes directly to the web server application. And from there, the application then sends it off to the website. Website then sends it back. The web appliance checks it out and then sends it back to the computer. So I know it's quite a very technical topic, not something that is generally brought up on the floor as far as connecting to the cloud. And it's, well, excuse me. So it's a very technical topic. It's not something that's often brought up. A lot of people want to keep their plant isolated, have no outside communication, have nothing coming in or going out. But with setting it up securely with web appliances and firewalls through the IDMZ makes it so that there's nothing actually being seen without being encrypted and decrypted, and there's no actual communication breakdown. So let's see, check to see if we have any questions. All right, so it doesn't appear that there are any questions. The presentation will be online, as well as the slides will be available to you. we as specialists are available to answer any questions in depth if you have any questions regarding today's topic. Thank you all for attending. Have a wonderful day.